It began with a flicker, barely noticeable, almost dismissible. A faint blip in the data streams from observatories across the globe. Something cold, silent, and impossibly fast slicing through our solar system in a way no natural object ever had. Hawaii's Mauna Kea, South Africa's Sutherland Observatory, telescopes spanning 5 continents, they all saw it first. And then NASA confirmed the unthinkable. A new object, uncharted, unbound by the familiar gravitational rules, and most chillingly, not from our solar system at all. Initially, it was easy to dismiss it as just another rock, a fragment drifting aimlessly through space. But the more scientists examined the data, the more unsettling the picture became. Its speed was extraordinary, 152,000 miles per hour. Its trajectory was unnervingly precise. Its brightness defied expectations for its size. And when astronomers traced its path backward through simulations, they discovered its origin: interstellar space. Possibly far beyond the Oort cloud, perhaps even toward the galactic core itself. This wasn't a leftover fragment from the solar system's formation. This had been traveling through the void, unseen, untouched, for tens of thousands of years. And now it had crossed the threshold into our celestial neighborhood. But the real question wasn't just where it came from. It was why now. For centuries, humanity had looked outward and found silence. Space had seemed indifferent, empty, serene. Then, in 2017, the first interstellar object appeared. Oumuamua, long and cigar-shaped, moving through the solar system like a phantom. In 2019, Borisov arrived, a comet, yes, but faster, stranger, more volatile than anything our scientists had expected. And now, this. Each object stranger than the last, each one forcing us to reconsider the very rules of the cosmos. The latest interstellar visitor was officially named 3I Atlas, after the high-speed sky-scanning system that first detected it between June 25 and 29. But Atlas hadn't just captured another asteroid. This was different. Its speed and trajectory defied prediction. Its reflections were too bright. And when the James Webb Space Telescope trained its massive infrared lens on it, the anomaly deepened. The object's brightness didn't match its apparent size. Based on how much light it reflected, it should have been enormous. Instead, the measurement suggested something smaller, implying a surface that wasn't rock or ice, but highly reflective metal, cold, and possibly hollow. Harvard astrophysicist Avi Loeb, who had stirred global debate by suggesting Oumuamua might be artificial, stepped forward again. He urged the community to look for non-gravitational acceleration, subtle changes in motion that the sun's gravity alone could not explain. If such deviations existed, they could mean this object wasn't drifting, it was navigating. And if it was navigating, then we weren't looking at a rock. We were watching a decision, a presence, a purpose. Consider the 2 interstellar objects that preceded it. Oumuamua had baffled scientists with its cigar shape, lack of a comet tail, and inexplicable acceleration after perihelion, showing no evidence of propulsion or outgassing. Borisov was different, clearly a comet, but faster, more volatile, more unpredictable than any comet observed in our system. Both left humanity with more questions than answers. 3I Atlas, however, combined anomalies from both predecessors. It reflected light like Oumuamua, yet moved with the trajectory precision of Borisov. It didn't behave like a rock, yet it couldn't be classified simply as a comet. And now, scientists whispered a theory no one wanted to voice publicly. What if these were not random events? What if they were part of a pattern, a wave, a deliberate sequence of contact disguised as chaos? Among all the models, simulations, and observation logs, one chilling question emerged. What if it isn't natural? When anomalies pile up, The brightness too high, the trajectory too sharp, motion inconsistent with gravity. The mind turns to one possibility: artificiality. Not aliens in the cinematic sense, but autonomous probes, messengers or machines engineered far beyond human capability. Loeb suggested we may have missed the message from Oumuamua, and now, 3I Atlas could be our second chance to decode it. Its surface properties, anomalous speed, and timing all suggested intentionality, or at least some form of engineering. As days passed, Webb and its ground-based counterparts gathered more data, converging on a conclusion that sent shivers through the scientific community. The object exhibited subtle, unexplained acceleration, unlike any cometary outgassing. It had no tail, no particle plume, no visible emission. Yet it shifted from predicted paths with eerie precision. Its infrared thermal signature was faint but consistent, stable, and directional, echoing the mysterious behavior of Oumuamua. Spectral analysis shattered expectations. Researchers anticipated silicates, iron, or ice. Instead, they found signs of advanced carbon structures, materials more commonly associated with engineering than with natural rock. Its spin revealed symmetry almost impossible for a random cosmic fragment. One side absorbed heat differently than the other, hinting at intentional design. Fluctuations in electromagnetic readings suggested internal complexity, cavities, layers, or structures unlike anything found naturally in our solar system. The implications were staggering. It wasn't a rock. It wasn't a comet. It was something designed. Then came the silence. NASA, ESA, ISRO, and other agencies that had released routine updates suddenly went quiet. Observational timelines disappeared. Raw Webb data was withheld. FOIA requests returned heavily redacted documents. Inside observatories, whispers of personnel being reassigned, restricted access to feeds, and internal reviews spread rapidly. The public narrative shifted from curiosity to silence. Something extraordinary had been found, and governments were scrambling to control the knowledge. The realization began to dawn: this object was no longer a data point. It was an inflection point. If artificial, it originated from a civilization capable of engineering a probe that could survive interstellar travel for millennia. If natural, it was so advanced, so rare, that it mimicked intelligent design with near-perfect fidelity. Either way, humanity's understanding of the cosmos was incomplete. And then, the more disturbing possibility emerged, not in journals, but in encrypted exchanges between scientists. What if this object was meant to be found? A cosmic test, an observer waiting for a civilization to become capable of detection. A silent message: you are ready. We are here. Now, watch, learn, and respond. For billions of years, the universe had been silent. And now, at the precise moment human technology reached a new threshold, AI, quantum computing, planetary exploration, something appeared that forced us to look. We wanted answers. We got a mirror. The James Webb Space Telescope, built to study galaxies and the early universe, had trained its instruments not on the birth of stars, but on our doorstep. 3I Atlas glided silently, precise, timely, and too perfect to be coincidence. Its passage through our solar system wasn't just an anomaly, it was a signal, one we might finally be capable of noticing. And now the question isn't whether we will find something out there. It's whether something already found us. Because perhaps the scariest possibility of all is this: we were never the observers. We were the observed. The universe is no longer silent. And it's staring back.